All right, everybody. Well, here we are with Amanj in another lesson of grade 10's book. So, in today's lesson, we're going to talk about lesson 4 under the title of inequality. So, you may know that inequality from the previous grades, especially grade 9. And just play it and go to the page in that way. Okay, so I hope that everybody is doing well. Lesson 4, grade 10's book, solving and representing linear inequalities in single step variable or in multi-step inequality. So, before going to those two types of inequalities, we have got something else we need to know about them. Like, for example, intervals, inequality symbols, and number line, how to show the result, how to show an interval and represent it on a number line, and vice versa. Okay, so first of all, let's just get familiar with the inequality signs and inequality symbols. We have got a table of them. Let's just fill this table together. Okay, so introducing the symbols of inequality and the way of interpreting them. We know that we have got 4 symbols of inequalities: less than, greater than, less than or equal to, greater than or equal to. How are we going to express them? For example, always we are going to read it from left to right. So from where to where? Left to right. So for example, here it says A less than B. How are we going to show it as an inequality? A less than B. And why it's written here negative? The result of it. For example, imagine A minus B. Okay, if A is 2 and B is 3, so 2 minus 3 would be negative. I hope that it is clear. And the next one is A greater than B. So how do we show A greater than B? From left to right, A greater than B. So this time, let's just say that, okay, what if 4 is greater than 1? 4 is greater than 1. So 4 minus 1 would be definitely positive, which is 3. Okay, so the result of that case is always positive. The result of that case is always negative. Perfect. We have got 2 more cases. What about A less than or equal to B? A less than or equal to B. For the less than part, the result is always negative. A minus B. When A is less than B, the result is always negative. But when, let's come to the equal part, when they are the same, the result would be 0. 7 equals to 7, so 7 minus 7, the result is 0. How about the last one? A greater than or equal to B. A greater than or equal to B. For the greater than part, the result is always positive. When a number is greater than another number, for example, 15 is greater than 14. So 15 minus 14, the result is positive. But if both sides are equal, because of that equal part, the result would be 0. That is regarding to inequalities symbols and inequality signs. All right. So let's go to the next slide and see what we have. So the thing that we need to know about the interval, like everything that you must know about interval is, right now I'm going to just define all of them. So let's just use black. Okay. Interval is a set of numbers that is like between 2 numbers, okay, 2 real numbers. Let's just show the definition. Okay. Interval is a set of numbers that includes all the numbers between any 2 real numbers. So it is a set. What kind of interval notations do we have? What kind of interval notation do we have? Let's say, let's start with like closed interval. That is the notation for closed interval. I hope that it is clear from like you guys as well. This is the closed interval. Okay, when we have, like, for example, 1 to 5, and a closed interval of 1 to 5. So that means that set of number includes the boundary point as well, like includes 1 and 5. All right. But how about open interval? We show them as normal parentheses. So this is what we call open interval. Okay. So open interval of 1 and 5. So what is the difference between these two? The difference is in closed interval, our interval includes these two numbers. But in open interval, so the interval doesn't include these two numbers. Okay, and how do we represent them on number line? So let's just draw a number line and see what is the difference between them on number line. So imagine this is our number line. Perfect. So for the closed interval, for both of them, we have got 1 to 5, 1 to 5, and 1 to 5. So perfect. Okay, for closed interval, by the way, we are going to say that, okay, from 1 to 5 and from 1 to 5. That is the set. That line shows the set of this interval, these numbers between them. Like it starts from, like, for this one, start from 1 itself, 2, 3, 4, 2.5, 3.5, and everything between 1 and 5, including 1 and 5 depth sets. Okay? Since we have closed interval, for closed interval, always we are going to shade these circles. So we are going to fill it, okay? It should be like closed and filled circle. But for open interval, always leave it as empty circle, okay? Do not color it, do not shade it, do not fill it, okay? That's why closed interval must be represented by a filled circle, and open interval represented, and we should show them with empty circles. That is the difference between closed and open interval on number line. So we have got something else that we call it half closed and half open. Okay, half closed. Let's say if we have something like 1 to open. And open 1, 2, 3, close. Okay, this is what we call half closed and half open. So from one side it's going to be closed, from the other side it's going to be open. How are we going to show it on number line? Easy. So make our number line. Let's just do it. Just use different colors. So from 1 to 3. Here is 1 and here is 3. So make circle and a line between these two. All right. So from left side it's closed, we are going to fill it the circle, and from left it's open, so leave it as empty circle. For the second one, again from 1 to 3, from left it's open, so we are not going to fill the circle. From the right it's closed interval, so we are going to just fill the circle. This is how we are going to represent an interval on a number line. All right. And I hope that it is understandable. Like there are some other cases for infinity. All right. Let's say if we have 1 to positive infinity and open 1 to positive infinity, and of course negative infinity to 1, but this time closed, and negative infinity to 1 open. How are we going to show these four on number line? Always remember that for infinity, when we have infinity in one side, so it's going to be always with open interval, not closed, because for infinity is just a symbol, a notation, so it's not a number. We don't know what is it. All right. Since we don't know it, so we are going to always put open interval for it, not closed interval. Be careful. For the first one, so if you have this 4 number line, perfect. For the first one, from 1 to positive infinity. So don't say, okay, here is positive infinity. Okay. So let's just say that that side, the right side is positive infinity, the left side is negative infinity. All right. So from 1 to positive infinity, 1 is closed, so we are going to shade inside our circle, and it goes on until positive infinity. Okay. And then, as an inequality, you can just show it in this way. Our x's, again, I'm going to repeat it. That line shows the x. Okay, so our x's are greater than or equal to 1. This is how we make inequality for an interval or a number line. Perfect. How about the next one from 1, again from 1 to positive infinity. So this time 1 is open, so we are not going to fill the circle. Okay, it goes to positive infinity. How are we going to show its inequality? So again, our x's are only greater than 1 without the equal because it's open. Okay. How about the next one? So from negative infinity to 1. So our x's are all smaller than or equal to 1. Smaller than or equal to 1. Why? Because it goes to negative infinity. Imagine here is 1. Since it goes to negative infinity, so we will shift, we will move toward the negative infinity. So it's going to go there. Do we have equal under the inequality symbol? Yes, we do. So we are going to fill inside this circle and it's going to be in that way. All right. How about the last one? So from negative infinity to positive 1. Let's say again 1 is here. Make our circle goes to negative infinity. Perfect. Are we going to fill it? No. Why? Because there is no equal, by the way, x less than 1. Only less than. Why? Because it's open interval. So there are 3 reasons. Because it's open interval, because the circle is like not shaded, it's not filled, and because all the x's are only less than 1. Only less than 1. That's why the interval is open here. So they related to each other. Open, not shaded circle, empty circle, let's say, without any equal sign, and open interval. They are related to each other, okay? They are related to each other. All right. And as well as closed interval, okay, equal sign under the inequality, and filled circle, okay? These 3 are also related to each other. Perfect. I hope that till now the story of interval and representing them on number line is much clearer to you, ladies and gentlemen. So let's go and see what we have next. Okay, we have got some examples here and we have a simple note over there. So the example underline these intervals on the number line. So we have to draw a number line first for each interval. Okay, that is the 4th one. Perfect. So let's just show them on this number line. Okay, so it says 0 till 3. 0 till 3. Okay, from the 0 side, our interval is open. Perfect. And from the 3 side, it's going to be closed, so we are going to fill inside our circle. Perfect. And for the next one, from negative 2 to positive 1, So from negative 2 to positive 1, both of them are going to be empty circle. Why? Because we have got open interval. About the next one, from 1 to positive infinity. From 1 to positive infinity. So do not write like here on the red one. So here you can write positive infinity. Even if you don't write it, it's going to be okay. So are we going to have filled or empty? Filled one, because we'll shade it, because we have got closed interval. Okay. How about the last one? So from negative 1 to negative infinity. Since it says negative infinity, we are going to shift to left, to negative infinity. Okay. So how about our circle? It's going to be shaded one, filled one, because our interval is closed. Perfect. And I hope that it is clear. So guys, you can just change, you can make example by yourself. Change these numbers and stuff. Then test yourself. Okay. We have got a simple note here. It says the interval, or the closed interval of a number to itself contains only 3. Why 3? Because the number is 3. So it can be 4, it can be 5, it can be -1, it can be 3, it can be any other number that you think. The interval, the closed interval of a number to itself is called degenerate interval. Okay, degenerate interval, and it's equal to the set of only that number. So the set of this interval is just the number itself. Perfect. So for example, this one is called degenerate interval, like from 5 to itself, which is 5. So the set of this interval would be only number 5, and that's it. And how are we going to show it on a number line? You might ask me, okay, imagine this is our number line, so number 3 is here, so it's going to be only a single spot, a single point. Okay, next question. Again, underline these intervals on the number line. I just want you to pause the video and try to do them by yourself and try to check it based on the previous slide that we did it. All right. So I will just do only one of them. Let's just do the second one. Imagine this is a number line. So 1 is here, 3 is here. So from 1 to 3, do we have open or closed interval? Open interval from both sides. That's why leave the circle like this, as empty they are. And I hope that you solved the rest by yourself. Perfect. What else do we have? When the number line is given, this time we will go oppositely, okay? When the number line is given and the question asks you to find an inequality for it, or show the interval of that number line, how are we going to solve it? It's another type of question, be careful. Write the interval and then the inequality equation based on the following graphs. So we have got one number line here, as you can see. It's from what to what? Look, our x, always that line represents x. Be careful. Okay. So our x's are between 2, that is 2 here, and less than 6. Okay. From the left side, as you can see, the circle is empty, so no equal under the inequality symbol. But from the right side, it's filled, okay? So we are going to have an equal under 6. So it means 6 is also included in that set. How are we going to show it as an interval? So you are going to say that, okay, from open 2 to closed 6. Okay, because from the left side it's open, empty circle, and from the right side it's closed because it is shaded. Okay. The next one is another x. So let's say our x, okay, look, all the x's are greater than 3. So greater than 3. Some students are doing like this, so less than positive infinity. You don't need to, because that means that all the x's are less than positive infinity and greater than 3. All right? Only that part is enough. So are we going to write equal under this inequality symbol? No, because the circle is empty. Okay? And as an interval, you are going to write, from open 3 to positive infinity. For infinity, always we have got open interval. Okay? And why do we have open here? Because the circle is empty. Okay. The next one, the same story. I will do this one and I will leave the rest for you in order to not make the video longer. Okay. So our x, I said that line is the x. All the x's are greater than and less than 2 numbers. So here, by the way, negative 2, from negative 2 to positive 4, And is the circle empty or shaded? So it's shaded, so we are going to write an equal under this inequality symbol from this side. And how about the other side, from the right side? It's empty, so leave it like this. So from negative 2 to positive 4, from negative 2 to positive 4 with open interval. And I hope that it is clear. How are we going to make inequality or write an interval for a given number line? Perfect. I want you to do these two by yourself, and I hope that you do them correctly. Okay, let's go to the properties. Guys, properties, I'm just going to mention them because they are easy to understand. So, addition property says that if A is less than or equal to B, if we add a small amount to both sides, still the inequality works. Okay? For example, we know that 2 is less than 4. So if we add 1 to both sides, still the inequality satisfied. Okay, 2 plus 1, 3, less than 4 plus 1, 5. That is regarding to these properties. You might ask me, teacher, are they important? Yes, they are, especially the multiplication and division. During the solution of a question, when you solve a question, you will need these properties, okay? So let's come to here and talk about a note that it is really very, very important. So note, if we multiply, I want you to write these notes in your notebook. If we multiply or divide an inequality by a positive number. If we multiply or divide an equality by a positive number, okay, the inequality symbol will not change. But, just make this but as red, but, it is the dangerous part, by the way. Okay, but if we multiply, multiply or divide, doesn't matter. So divide by a negative. Here is the point. By a negative number, the inequality symbol will change. Symbol will change the direction. We're going to find out what I mean by that. Imagine, let's just give it as an, okay, white. I hope that white is clear to understand, to see. Let's say 3 is greater than 1. Okay, 3 is greater than 1. If we multiply this inequality by positive 10, from both sides, by the way. 3 times 10, 30. 1 times 10, 10. Since we multiplied by a positive number, so the inequality symbol doesn't change. Okay? But if you have the same thing, like we know that 3 is greater than 1. If you multiply both sides by negative 10, let's see what will happen. So 3 times negative 10, negative 30. 1 times negative 10, negative 10. Right now, I am pretty sure everybody knows that negative 10 is greater than negative 30. That's why that inequality symbol will change. So basically, we will say that if we multiply an equality by a positive number, the symbol will stay the same, doesn't change. But if we multiply or divide by negative number, the symbol will be changed. And I hope that this is clear. So we will use this idea when we are solving questions regarding to inequalities. Okay? By the way, this property, all of them, the notes are regarding to these 2 properties. You may just snap them and write it down them in your notebook too. Perfect. So let's go to the inequality. The type of inequality, we have got multi-step inequalities and of course solving linear single variable inequalities. So basically we have multi-step and one-step, let's say, or single-step inequalities. Perfect. So to solve both type of inequality, we have got a simple way. And if you understand that way, that would be enough to solve every single question regarding inequalities. Okay, no matter it is multi-step or single-step. When you have an equality, always, especially multi-step one. For the single-step one, it's okay, it takes only 1 step, but I'm talking about the multi-step. When we have more than one variable term, always move the smaller term, the smaller variable term, to the bigger one. And then in that case, the numbers are going to move to the other side. Okay, let's just find out what I mean is to solve both single and multi-step inequalities, move the smaller variable term to the greater one, then shift the numbers to the other side. What I mean by that, let's just come to here. We have got single step, then we are going to come up with multi-step. Don't worry about it. Okay, so here we have got only one variable term, so leave it. Since it's positive, it should stay at the same place, and move the number to the other side. Okay, move the number to the other side. So when we move a term from one side of the inequality, just like equation, when we shift that term, the sign of it will automatically change. If it is negative, it's going to become positive. Therefore, we have got x less than positive 7 minus 2, positive 5. How are we going to show it on a number line? You are going to say that, okay, this is our number line. That is 5. Imagine this is 5. X is less than 5. So x is less than 5, which is, goes to negative infinity. Our x's are less than negative, positive 5. All right. How about the next one? The next one, let's just change the color. Here, again, move these negative 2 to the other side. So it's going to become positive 2. Right? And then we are going to have negative x greater than 10. So since it's negative, there is a negative with it. Remember the note that before this slide I mentioned it. We must make the sign of that variable that we have positive. So it's negative here. So multiply it or divide by a negative 1. It's going to be enough to make this one positive. And 10 divided by negative 1, it's going to become negative 10. And here we have got x. But since we divided by negative number, the sign of the inequality will change, the direction of it. Okay, since it's in this way, so it's going to become that way. All right, and the number line, of course, would be in that way. So here is negative 10. Again, our x's are all smaller than negative 10. Leave this one empty because there is no equal here. And I guess this is enough. How about the third one? So x minus 10 less than or equal to 6. Move this number to the other side. It would become positive 10. Right? So then we are going to have x less than or equal to. Be careful, huh? Less than or equal to. 6 plus 10, 16. Okay? And then we are going to have our number line. So 16 is here. Our x's are all less than or equal to. So we need to fill it. Because there is equal under the inequality sign. So this is how we are going to show, solve an inequality and show it on number line. And of course, if it asks you to write an interval for it, so it's easy. X's are less than or equal to 16. So it means from negative infinity to positive 16, since there is equal or the circle is filled, so we have to put closed interval. This is all about single step inequality, and I hope that you solve that examples that left by yourself. Let's go to the multi-step. Okay, multi-step one. For multi-step, exactly, we will use that note that it was in a yellow, I think, rectangle. So we have got 2x and negative 5x. So which one is smaller? Don't say 2. It's negative. So negative is always smaller than positive. Therefore, move the smaller one to the bigger one, and then the number will go to the other side. I hope that you did understand that. Always move the smaller variable term to the bigger one. In that case, negative 5x will become positive 5x, so 2x plus 5x less than 6. That's negative 8 is going to come here and will become positive 8. So what are we going to get is 2x plus 5x, 7x, less than 6 plus 8. Excellent, 14. And is this the final answer? Absolutely not. So we have to isolate x. We have to make x alone. So divide both sides by 7. Divide both sides by 7. 7 will kill 7. X less than. We divided by positive number, so don't change the direction of the inequality. 14 divided by 7, 2. So show it on a number line. Here is 2. It says x less than 2. So x less than 2, which goes to negative infinity. And since there is no equal, so the circle would be empty. Okay. The next one, there is a fraction. I know that you guys, most of you hate fraction. When you see fraction, you are going to say, how fraction again? No, fraction is easy to be removed. So multiply all these fraction, all these inequality. If you hate fraction, multiply everything by 2. Okay? Then that 2 will cancel this 2, and we are going to have only 1x. 2 times negative 1, negative 2. Less than or equal to 2 times x, 2x, plus 2 times 2, 4. Perfect. So we have got 1x and 2x. Move the smaller one to the bigger one, and the number goes to the other side. Okay, in that case, 2x, if x comes to here, it's going to become negative x. Right? Greater than or equal to. 4 will become negative 4, and we have got minus 2 here. 2x minus x, x, greater than or equal to negative 4 minus 2. Perfect, negative 6. Okay. So our number line would be in this way. Let's just make the number line, okay. And negative 6, imagine it's here. It says x greater than negative 6 or equal to. So from here to positive infinity, and is that circle would be empty or filled? Of course filled. We'll shade it. Why? Because there is an equal sign under the inequality sign. Perfect. That is also about like multi-step inequalities, and I'm pretty sure you got it, guys. So regarding to the single step and multi-step, do the rule that we said, move the smaller one to the bigger one, and then shift the numbers to the other side. That's going to be enough to solve every single inequalities problem. Okay, what do we have next? The next thing that we are going to study is compound inequality. Compound inequality is like about and or. Remember, we studied them in grade 9. When we have and, so we are dealing with intersection parts. When we have or, we are facing with union stuff. Let's just make it clear and clarify it, okay? When we have and, so and notation is just like this, the Kurdish A, okay? It is like that. That stands for and in inequality, for showing two inequalities. Oh, by the way, let's see what we else have. So here we have got or, so Kurdish 7. So Kurdish 8 stands for and, to show two compound inequality with, and or are going to be shown by this notation, which is 7, or we can say that it's a V, English V. Okay. Then we have got this note. When two inequalities are connected by the conjunction and, the solution set is the intersection of both solutions. So we said that when we have and, immediately we need to think about intersection. Okay? What I mean by intersection, we are going to come to it. So when two inequalities are connected by the conjunction of and, the solution set is the intersection of both solutions. We are going to have examples, don't worry about it. And when we have or, when two inequalities are connected by the conjunction or V, the solution set is going to be union of both solutions. So let's just simplify it. If we have and, we are going to have intersection. If we have or, we are going to have union. Okay, union of the solutions. Perfect. Teacher, we did not get it. Perfect. Let's just go to the examples and see whether we have examples or not. So solve the inequality of x plus 1 greater than 2 and. So in another term, we can say that upside down v or Kiddish 8. And that inequality, show them on the number line. Perfect. So first of all, let's just solve them. X plus 1 greater than 2 and, let's just write it here, and 3x minus 2 less than 7. Perfect. Let's just solve them. I would like to change the color to make it clear. Okay, black is perfect. Move this one to the other side. So x greater than 2 minus 1 would be 1. That is the first solution. How about the second one? Move this negative 2 to the other side. So we are going to have 3x less than 9. And divided by 3, divided by 3. So x less than 3. That is the second solution. So let's show them on a number line. Big number line like this. Be careful. So the first one, since it says and, we need to find the intersection part. Intersection area. Okay, x greater than 1. Let's say 1 is here. Okay, so x greater than 1. It goes to positive infinity. And x less than 3. If 3 is here, so x less than 3. You see, these are the two solutions. Right now, the intersection part means that that part that both of them are over each other. Okay? So, this part, as you can see, these two are like over each other. So, we call that part the intersection part. And the interval is going to be like from 1 closed, open 1 to 3. Okay? Because since it's open here, so we are going to have open 1, and since this one is open here, so we are going to have open interval. This is how we are going to find and solve the solution of compound inequalities regarding and. So whenever it is and, we need to find the intersection area, the intersection part. Perfect. I'm going to explain one more time quickly. So, first of all, x plus 1 greater than 2, x plus 1 greater than 2. Move this 1 to the other side, so we are going to have negative 1. So, x greater than 2 minus 1, 1. That is the first solution. The second solution is 3x minus 2 less than 7. Okay, move this number to the other side, so it's going to be 7, and this negative 2 will become positive 2. So, 7 plus 2, 9. Since 3 is not alone, we need to make it alone by dividing by 3 divided by 3. So this 3 will go with this 3. X less than 9 over 3, 3. That is regarding the second solution. Right now, we are going to bring our solutions on a big number line and show them, represent them. So the first one is x greater than 1. X greater than 1 with open circle. Why? Because there is no equal. And the second solution is x less than 3. So 3 is here, x less than 3 goes to infinity, negative infinity. Now, since we have and between these two inequalities, we are going to take the intersection part. What is the intersection part? It's that part that both graphs are over each other. Okay? So from 1 to 3, both of them are together. For example, in that part, we don't have that solution, and in that part, we have no solution of that part. Therefore, only for and, we will take only the intersection part. If you want to check whether your result is correct or not, take a number in this interval. Let's say the best one is 2. So that 2 should work for both of them. Okay, 2 plus 1, 3. 3 is greater than 2. Perfect, it's correct. How about here? 3 times 2, 6. 6 minus 2, 4. 4 is less than 7. Therefore, our solution is definitely correct. This is how to evaluate. Perfect. Compound inequalities. Try this one. Let's just try this one. Okay, x minus 1 less than or equal to 3. And x minus 2 greater than 0. Show them on the number line. Okay, we have got this compound inequalities. This time again and. So intersection part, be careful. Whenever it's and, think about the intersection part. Okay, x minus 1 less than or equal to 3. Move this negative 1 to the other side, so it's going to become x less than or equal to negative 1, it's going to become 1. 1 plus 3, 4. And the second one, x minus 2 greater than 0. Move this negative 2 to the other side, so x greater than negative 2 will become positive 2. That is the second solution, and here is the first solution. So here is our number line. Okay, we have 2 and 4 as well. So from left to right, read it. X less than or equal to 4. So less than or equal to. Since there is equal, we are going to shade it. Okay, to negative infinity. How about the second one? It says x greater than 2. X greater than 2, just greater than. So we are not gonna fill that circle. Okay, so where is the intersection area? That areas that both graphs are over each other, so here is going to be the intersection. Okay, so if you are going to show it as a number line or as an inequality, as an interval, we are going to say that, okay, from 4, 4 is here closed, and from left side it's 1. But be careful, 1 is open, because 1 doesn't work for one of them. So the intersection means that number should work for both inequalities. So in that set, let's just try 1. Okay, 1 minus 1, 0. 0 is less than 3. No problem with that. How about here? So 1 minus 2. 1 minus 2, it's negative 1. So negative 1 is not bigger than 0. That's why we made open interval here, because it shows that that set doesn't include 1, because 1 doesn't satisfy that inequality. A number that is going to be included in that set, it should work for both inequalities. For example, let's try 2. Okay, 2 must be true for both. So 2 minus 1, 1. 1 is less than 3, and it's correct. How about here? 2 minus 2. So it should be. Oh, by the way, it's 2. Come on, it's 2. Sorry, I want you to just come back to the solution. Wait a second. It's 2, not 1. Sorry. So 2 is not included. Be careful. Look, x greater than 2. I thought that this is 1. My apology. So since it's 2, 2 is not correct. Why? Because, okay, 2 was perfect for this one. 2 minus 1, 1. 1 is less than 3. But 2 doesn't work for here. Why? Because 2 minus 2, 0. 0 is not greater than 0. 0 is equal to 0, not greater than 0. That's why we put open interval for this side, because 2 is not included in this set. Okay, how about 3? So let's just try 3. 3 minus 1, 2. And 2 is less than 3. Perfect. How about this one? So 3 minus 2, 1. 1 is greater than 0. Since it works for both inequalities, so 3 is included in this interval. And how about 4? Since we have got 4, we have closed interval for 4, so 4 also is a member of this set. Let's see whether it works for both sides or not. So 4 minus 1, 3. 3 is equal to 3. There is equal. Okay, so still it's correct. Therefore, 4 is correct for that one. How about here? 4 minus 2, 2. And 2 is definitely greater than 0. Therefore, 4 is included to the solution. And I hope that this is clear, guys, to you. Remember, that was 2. My bad, I wrote just 1. So I want you to just check it again. How about OR? Okay, for OR we have got union. What I mean by union, we will find it out right now. So we have got two inequalities. First one is 2x plus 1 less than negative 3. Move this one to the other side. So we are going to have 2x less than negative 1 minus 1, negative 4. Divided by 2, divided by 2. So x is going to be less than negative 4 divided by 2, negative 2. That is the first solution. How about the second solution? Let's just find it out. X minus 4 greater than or equal to negative 1. Right? Move this negative 1 to the other side. So x greater than or equal to negative 1 plus 4, it would become 3, positive 3. Right? So x greater than or equal to 3. Draw our number line. Draw our number line. Perfect. So we have here x less than negative 2. Imagine negative 2 is here. X less than negative 2 means go to negative side, which is negative infinity. And since there is no equal, so leave it as empty. Perfect. And then we have x greater than or equal to 3. Let's say 3 is here. Greater than means go to right side, positive infinity. All right? So positive infinity and negative infinity. Perfect. And since it's with equal, I want you to just shade it. So in OR, we don't have intersection, we have union, which means all those solutions that comes from each of these inequality. Okay? For example here, negative infinity to negative 2 open, union, or you can just show it with the V notation, union. From 3 closed, it's filled circle, so from 3 to positive infinity. For infinity, always put open interval. This is how we are going to represent the solution as an interval for a compound inequality that includes OR between the inequalities. I'm going to repeat it quickly. We have got two inequalities, we solved them. This is the first solution, that is the second solution. So we put them on the number line. We said that since it's OR, we are going to take the union between them. Okay? Union is all those solutions that works at least for one of the inequalities. Okay. And this is how we solve these kind of questions. I hope that we have got one more question. Let's just check it. Yes, we have got. It seems that we have it. Hopefully, yes. Perfect. Solve these inequalities. That is OR. When it is OR, so union. Perfect. So the first one, 2x minus 1 less than or equal to 1. Okay, less than or equal to 1. So move that negative 1 to the other side. We are going to have 2x less than or equal to 1 plus 1. That negative, when we move it to the other side, it's going to become positive 1. So 2x less than or equal to 1 plus 1, 2. Is this the solution? No. Divide both sides by 2, divide both sides by 2. So finally, x is less than or equal to 1. That is the first solution. And the second solution comes from the second inequality. Be careful. So x minus 4 greater than 0. Move this negative 4 to the other side. So we are going to have x greater than 4. That is the second solution. So create and make your number line. Okay. First solution, x less than or equal to 1. Let's say 1 is here. Okay. So 1 is over there. X is less than or equal to 1. Less than means go to left side. Since there is equal, feel it. Okay. And how about 4? So 4 is here. So x greater than 4. X greater than 4 goes to positive infinity. And here it goes to negative infinity. Are we going to fill it? No, because there is no equal. Okay, so how are we going to represent the solution as interval? You are going to say, okay, from negative infinity, open interval, to 1, closed interval. Why? Because it's filled. Union, okay, from 4, open interval. Why? Because it's empty. To positive infinity, open interval. That is how you are going to show an inequality, a compound inequalities solution when it takes, like when it includes OR in interval way, in interval form. And I hope that this lesson, just like the previous lessons, were fruitful and beneficial for you guys. I hope that you follow my videos and watch them like 2 times, 3 times in order to get and catch every single point and how to solve the questions. And I hope to see you, inshallah, in another video. See you and take care of yourself. Thank you for listening to me.